In this video, we will learn about linear functions. Now, what is a linear function? Well, it's a function that creates a line. All right, we see the word line in the word linear. And our formal definition is a function that can be written in the form of f of x equals mx plus b. And as we stated, the graph would be a straight line. And notice that x, this variable, must be raised only to the first power. Now with a linear function, or with a line, we can find what we call the slope. The slope of a line is how steep the line is, or in other words, the value of the rise or fall in a linear function. So in a function, if you have f of x equals mx plus b, the letter m in that function, m is going to be your slope. And slope, by definition, can be quantified as the rise over run. So how high up is it going, divided by how far left and right is it going. Another way of expressing the slope is we can think of this as the change in y over the change in x. And actually we can express this in math notation with a capital delta. So this is a Greek symbol, so it's a triangle, but this means change in. So you have the change in y divide by the change in x. So that's another way of expressing the same thing. So how do we calculate the slope of a line that connects 2 points? Well, as we stated, if we have 2 points, we can find the rise divided by the run. And to calculate that, we subtract the y values and then divide it by the subtraction of the x values. So for example, let's say we had the points of -3, 2 and 1, 5. So if these are your 2 points, we can think of this as x1 and this as y1. And then over here, x2, and this is your y2 value. All right, so if you think of it like that, in the formula, we do y2 minus y1 over x2 minus x1. So we take 5 minus 2, divide by 1 minus -3. So that would give you 3 over 4 as the slope. So m, the slope, would equal 3 over 4. So we can calculate the slope between any 2 points by doing that process. Now we're going to look specifically here on this next slide at horizontal and vertical lines. So a horizontal line is a line that is horizontal or straight across left to right. And let's say we pick 2 points on this particular horizontal line. Here we have -2, 2 and then 1, 2. If you try to find the slope of this line from these 2 points, this would be x1, y1, x2, and y2. You can use the formula where you do y2 minus y1, so 2 minus 2, over x2 minus x1, so 1 minus -2. This would give you 0 over 3, which would equal 0. And that would be true for any horizontal line. The slope of a horizontal line will always equal 0. And then what about a vertical line? So here we see a vertical line, and if we pick 2 points, let's say 3, 1, and 3, -2, and you were told to find the slope between these 2 lines. Well, if this is x1 and y1, this is x2 and y2, you can plug those numbers into the slope formula, where you take y2 minus y1, so -2 minus 1, over x2 minus x1, which is 3 minus 3. That would give you -3 over 0, which would be undefined. So remember, if the 0 is on the top, it's going to be 0. If the 0 is underneath, it is undefined. And this will be the case for any vertical line. The slope of any vertical line will always be undefined. Now let's talk a little more about our function f of x equals mx plus b. So we stated earlier that m in this function would be the slope, but then b we've not talked about yet, but that would be your y-intercept. So the y-intercept is where it crosses the y-axis. All right, so it's going to be a 0 for x, and then whatever b is, that's your y value. That's where it crosses the y-axis. So for example, if we had f of x equals 3x minus 2, the slope would be 3, which is the number with the x term, and then your y-intercept, the number out here, that's going to be -2. So your y-intercept would be at the point 0, -2. That's where it crosses on the y-axis. And then we can use this function, if it's already in slope-intercept form, we can use this to graph very quickly. So let's say we had f of x equals 2x minus 1, and you were told to graph. Well, here the slope would be 2. This is a number with the x term. Then your y-intercept is -1. So it's crossing on the y-axis at -1, and the slope is 2, which, remember, slope is rise over run. So we can think of this as 2 over 1, where 2, the number on the top, is your rise, and the 1, the number on the bottom, is the run. Meaning from this point here, we have directions on where to go to find your second point. We can go from this point up 2, and then to the right 1. And we get that second point, which we can then graph and connect the dots to create our line. If you wanted, you can actually get more points. You can go from this point up 2 to the right 1 to get a third point. You could go from this point here, and you can actually have it as -2 and -1. So it's maybe kind of weird, but you can do that because -2 over -1 is still +2. So you could go down 2 in the negative direction, and then to the left 1 in the negative direction for the run, and we get this other point down here, which would still fall on the same line. Now you don't need all those points to create your line, but you could do this infinitely to get an infinite number of points if you wanted. Now let's try another example. Here we have 2x plus 4y equals 8. Now this equation is not in slope-intercept form at the moment, but we can put it into slope-intercept form, where we get y equals, and then something times x, and then plus a number. So we can solve this for y by subtracting 2x to the right side. That would give you 4y equals -2x plus 8. And then to get y by itself, you can divide everything by 4. That now gives us y equals -2 over 4, which is -1/2, times x, plus 8 over 4, which is 2. So if you were to graph this point, the slope is the -1 over 2, this number with the x term, and then b, your y-intercept, would be +2. So if your y-intercept is +2, that means you go up 2 on the y-axis. And then the slope is -1 over 2, so you can put the negative with the 1 or with the 2, it doesn't matter. If you put it with the 1, that would be a negative rise. That means we go down 1 from this point, and then the run is a +2, which means it goes to the right in the positive direction to get to this point right here. And again, we could keep going. We could go down 1 again and over 2 again to get a third point, or you could put the negative down here with the 2 and make the 1 positive. So you could go from this point up 1 and to the left 2 to get another point. Now again, we don't need all 4 points. All we need is 2 points, but we're showing you that we could get more points if you wanted. Next, we have what is called point-slope form. What this is it's a form of the equation that we can use to find our equation if you have just the point, a point on the line and the slope of a line, right? Because we normally need a slope in the y-intercept, but if we have the slope in just any point, we can use this form to determine the equation of the line. And this form looks like this, where we have y minus y1 equals m times x minus x1 in parentheses, where m is going to be the slope, and then your x1 and y1 is a point on the line. So how do we use this? Well, here's an example where we are told to find the equation of a line with slope of -2, and that passes through the point 1, -4. So what we can do is we can take that point-slope form, we can plug in place of m, plug in -2, that's your m value, and then x1 would be the 1, and then y1 would be the number -4. So what we have is y minus -4 equals -2 times x minus, and then x1 was 1. So now we have an equation, but we can rearrange this and get y by itself, so that way we have the slope and the y-intercept on one side. So this would be plus 4, and then we can distribute the negative 2 to get negative 2x plus 2. So we have y plus 4 equals negative 2x plus 2. Solve for y by subtracting 4 to the right side. When you do that, we now have y equals negative 2x minus 2. So what we've done is we have taken the point that we had, and we took the slope, and we used that to find our equation, which we then put into slope-intercept form, like this. And then from here we could graph that equation if we wanted. Now our next example is going to take that one step further, where here we are given 2 points, and we're trying to find the equation of a line that goes through those points. So we're increasing in difficulty, which will take one extra step. And here, for example, we are given the points negative 3, 2, and 0, negative 1. And we're trying to find the equation of the line that connects those points. So to do this, okay, to create our equation, we need to find the slope and we need the y-intercept. So we can start with the slope. All right, we already learned how to find slope by using our slope formula, where we do y2 minus y1 over x2 minus x1. So this could be x1, y1, x2, and then y2. So you plug those numbers into our formula, you subtract the two y values, negative 1 minus 2, and then divide by, and then subtract the x values, 0 minus negative 3. That gives you negative 3 over positive 3, which would give you negative 1. So we have the slope now is negative 1. And then from here, this is just like the problem we did on the last slide, where we had a point and we had the slope. Now here we have 2 points where we can actually pick which point we want, but we can use that same process to find the equation. So we can use point-slope form, where we have y minus y1 equals m times x minus x1. So y1, we can pick either point. Let's pick this second point here, because we have a 0, which will make it a little easier. So let's use this point to plug in for y1 and x1. So for y1 would be negative 1, x1 we're going to use 0. So we have y minus negative 1 equals, and then m, your slope is negative 1, times x minus, and then x1 was 0. Now we can solve this. We have y plus 1 equals, and then negative 1 times x on the right side, which is negative x. And then bring this 1 to the right side by subtracting. So we now have y equals negative x minus 1. So again, this is using 2 points to find the slope, or to find the equation of a line. Next, we're going to talk about parallel and perpendicular lines. Now, parallel lines are lines that never intersect. So they are 2 lines in the same plane that never intersect. And what is true with parallel lines is that the slopes are going to be equal. Perpendicular lines are 2 lines that intersect at a 90-degree angle. And their slopes are negative reciprocals of each other. And mathematically, we can express it like this. So the slope of the first line is going to be the negative reciprocal, which is 1 over the slope of the other line. So we can use that information to answer different questions. So on the next slide, here we have an example where we're trying to find the equation of the line parallel to this line of y equals 3x plus 2, and that also goes through the point 2, negative 4. All right, well, if it's parallel to this line, okay, that means the slope is going to be the same. The slope of this line is 3, so the slope of this other line would also be 3. So we know the slope is 3, and we know it goes through the point of 2, negative 4. So from that information, we can now find the equation of the line that has a slope of 3 and 2, negative 4. So using point-slope form, which says that y minus y1 equals m times x minus x1, we can plug in information to find this equation. So y1 would be negative 4, that's your y value. So y minus negative 4 becomes plus 4. And then m is 3, and x minus x1 would be x minus 2, that's your x value. and this would be your equation, which we can then rearrange to put into slope-intercept form. So on the right side, we can distribute. We get 3x minus 6, and then bring this 4 over to the right side. So now we have y equals, and then 3x minus 10. So the equation of the line that is parallel to y equals 3x plus 2 and goes through the point 2, negative 4 would be y equals 3x minus 10. And now here with this example, we are doing the same kind of thing, but now we're going to try to find the equation of a perpendicular line. Here we have the equation of y equals negative 2/3 x plus 4, and we're trying to find the equation of a line that's perpendicular to that and goes through the point 3, 1. So using that equation that we were given, okay, the slope of that line is negative 2/3. The slope of the line perpendicular to that would be the negative reciprocal. So you change the sign from negative to positive, and then reciprocal means we switch the top and the bottom, and now we get 3 over 2. So the slope of the perpendicular line is 3 over 2, and we know it goes through the point of 3, 1. So we know the point, and we know the slope, so we can use our point-slope form to find the equation of the line. Our point-slope form is right here, where we have y minus y1 equals m times x minus x1. So m, the slope of the perpendicular line, is 3 over 2, and then x is going to be 3, y is going to be 1. So we have y minus 1 equals 3 over 2 times x minus 3. So now from here we can distribute the 3 halves by multiplying with the x and the negative 3 over 2. That gives you 3 over 2 times x minus 9 over 2. And then solve for y by adding 1 to both sides. So now we have y equals 3 over 2x, and then minus 9 over 2 plus 1. 1 is 2 over 2, so we have negative 9 over 2 plus 2 over 2, that's negative 7 over 2. So this here is the equation of the line that is perpendicular to y equals negative 2/3 x plus 4 and goes through the point of 3, 1. Now to finish off the lesson, we're going to look at an application, which is a word problem. And here we have a fashion designer that makes and sells hats. The material for each hat costs $5.50, and the hats sell for $12.50 each. The designer spends $1,400 on advertising. And the question is, how many hats must the designer sell to break even? So to do this, there's probably different ways you can think through the setup of this problem, but realize we have two different things going on. Okay, we have the cost, so the cost to make his hats, and then also we have revenue, which is the money he earns. Okay, and the question is, how many hats must he sell to break even, which means the cost would be equal to the revenue. All right, so that's kind of the general big picture of what we're trying to do. And now we can fill in the details with our equation. So the cost says here that the material is $5.50 for each hat. So it's going to be $5.50 times the number of hats, so times x. And then he also has a cost for advertising, which is a flat rate of $1,400, so plus $1,400. That is his cost. His revenue is the money he's earning, and that's found right here. He's selling each hat for $12.50 each, which can be expressed mathematically as 12.5 or 12.50 multiplied by x. All right, so what we have is an equation that we can then solve. So we have 550 times x plus 1,400 equals 1250. 1250 times x. So this is a linear equation. All right, this would create a line. And we can try to solve this. So we can bring x's together. We can subtract 550 from both sides. We can bring that to the right side. So 550x from both sides. We now have 1,400 equals, and that would be 7. So 7 times x. and then divide both sides by 7. Now we have x equals 1400 over 7. That gives you 200. So the answer is that the designer must sell 200 hats to break even. And that concludes our lesson for today. We will see you next time.